Good morning. My name is Shane McGraw, Outreach Team Lead here at the SEI, and my pleasure again today to introduce our first presentation. And this talk will be SysML to AADL Bridge, automating the translation of SysML into AADL for Analysis and Refinement by Hazel Shackleton. Hazel is a software engineer at ACVIP Labs with extensive experience developing complex systems with safety, security, and real-time requirements. This includes use of SysML and AADL for the requirements capture, system specification, and design analysis. And she has earned 4 patents for her work. Hazel, welcome, all yours.
Thanks, Shane. As you said, I'm Hazel Shackleton at ACVIP Labs, and I first used visual programming language to design and implement a system 25 years ago. I did the math, and that's actually a bit scary. More recently, I've been implementing AADL tools that work with OSATE modeling environment. Today, I'd like to present work that Dr. Steve Vestal and I have been developing for the last couple of years. We actually started in the fall of 2019 with an advisory group of Army aviation system integrators and suppliers. This tool was developed under JMR, the Joint Multi-Role Mission System Architecture Demonstration, and was something that kept cropping up as a specific need that could fill a missing piece in the development process. Over the years, I've used many tools and helped develop lots of models with various domain experts and teams, but I've yet to find the silver bullet for model-based development. Some tools are really good at capturing requirements, some are great at simulation or physical systems. And there are many programs that look at crossing and sharing the data across those models. So this program is really just a very small step in the direction. But I'd like to think the best part is that it works now and can aid developers immediately, both SysML modelers and AADL developers, and something that should benefit many stages of a system's lifestyle. I'm hoping to focus most of our time today on looking at how we can use the tool in the real world. But before I get to those demos, I'm going to talk about why we think this is important and what our goals are for the tools and how they might fit into a development workflow. I also want to stress the supporting documents and example models that we've made available. And I'll be honest with you to the current limitations of our tool and where our plans are to move us forward. The YouTube chat messages are being watched by Steve Vestal, and he's agreed to answer any of the really quick questions, and hopefully we'll have time at the end for some of the more complicated ones. So the biggest thing I want to get across today is that we are not attempting to convert all of SysML into AADL. We are taking those pieces of SysML models that are most relevant to AADL analysis and modeling and converting those pieces into AADL. There's no reason to model for model's sake. Generating thousands of lines of code, while nice, is meaningless if the data or components of the model needed for analysis are missing. To select the parts of the SysML model, we allow blocks, ports, connections, and other SysML elements to be stereotyped using our SysML AADL profile. This profile allows the developer to go directly into diagrams or containment tree and identify the elements to translate. This is something I'll illustrate in our first demo in a few moments. But first, I want to back up a step and talk about what we'll be translating into. Each block in SysML needs to be identified as a particular component type in AADL, where, to be clear, abstract is a type, which can be refined later for those cases where the details aren't available. SysML allows a lot of flexibility in how it is used and what blocks and arrows can represent. AADL has very clear semantics, and we rely on those to define what each SysML element is translated into. For those who were listening to yesterday's talk from Sam Proctor, he spoke of the work they've done with the Standards Committee to make AADL semantics clear and meaningful. A thread in AADL has a very specific meaning, as do processors, type supports, and all the way down to the timing properties on those elements. Everyone who references the period or stack size on an AADL thread will agree on the meaning based on the underlying semantics and standards. The profiles we've developed cover all the core AADL components and their related property sets. We've also modeled profiles with specific properties for ARINC 653, MILS, SSF, BEST, or MADS, and I know SEI has been working on a profile for some of their custom property sets. These profiles are available for both Magic Draw or Cameo Enterprise Architecture, and also for Spark's Enterprise Architect tools. They do not require the Bridge tool to be installed to be applied, so a developer can add the stereotype information and still pass the model back and forth across their organization or across organizations without worrying about our AADL Bridge. Here's an excerpt of some of the mapping our profile can provide. If you're knowledgeable with AADL, you'll immediately notice that the various component types, abstract data, subprograms, threads, are all mapped from SysML blocks. So each block in SysML will be translated into both a type and an implementation in AADL. We've also included reference to the AADL standard, as again, it's those underlying semantics that make this transition useful across platforms and performers. We're going to spend more time looking at feature groups and flows during the demo, but I do want to point out that our profiles include stereotypes for elements in internal block diagrams and sequence diagrams, as well as the package and block definition diagrams, and that these stereotypes include their respective properties, so you can assign a latency to a flow or a direction to a feature group. Now here's where things get fun. We are completely aware that there are other tools out there, and many of them can generate AADL packages. One of AADL's great strengths is its integration ability. Packages in AADL can be seamlessly integrated together. This is perfect for models exchange across platform performers, or for configuration management where different models using different tools need to work together. The face-to-face tool is a great example, but many performers also have their own code generation tools. So we can take face data type specification or UML generated package and add it to our SysML generated packages. And with just a few lines of code, create a system that includes both. We can run analysis on this integrated system, or we can refine our generated code without modifying that code. This is something else we'll jump into in a bit. But before we get there, I want to reiterate our key goals for this tool. We want both SysML users and AADL users to be able to work in their environments in a natural way. I'm sure you can all point to a person in your organization that knows how to do everything. But in general, we found that developers have specialities or preferences, and we want to support and optimize those skills by allowing a clear interface between the two environments. With the tool comes a detailed profile and modeling guidelines document and a set of SysML example models. It's our hope that these documents are enough to get things started, but we're also available for questions. Here are some of the topics covered in our documentation, and it goes into a lot more detail than I'm going to cover today. So I just wanted to point you there if you have specific questions, but I also wanted to highlight the first two items here, names and namespaces, and allocation and binding relations, because I'm not going to have any time to talk about them today, and they're both pretty critical to much of AADL modeling and analysis. I don't need to think that we completely overlook them. I would be completely remiss before I get to the demo if I don't thank everyone who helped narrow the goals and help with the requirement stage of the development. And of course, the number of existing tools that do or have done similar things in the past, especially since I'm sure some of those developers may be in the audience. This work is very targeted on purpose, and I'm grateful to all who participated on the SysML AADL working group. Hopefully we've met your needs or are moving in that direction to support you. So on to some demos. These have been pre-recorded, so hopefully things will go well, but I have noticed the video freezing up, so we'll just cross our fingers on that. I'm going to start with a very simple example, which we'll build on as we go. This model is based on our Getting Started SysML example, which is included with the tooling. And in this case, we're going to pretend that we have an existing SysML model representing an air vehicle with a cockpit, a sensor, and a mission system, and that we wish to take this rather contrived system and run an AADL analysis on it. I'm also going to assume the developers already added the AADL profiles as a usage. So the first thing we need to do is apply the stereotypes from that profile. So here we will assign the package to become an AADL package. This will tell the tool that this is something we actually care about if there's multiple packages to choose between. We will make this interface block an AADL feature group. And then we will assign the other items using a shortcut here of just dragging it directly from the profile onto the block. We will make cockpit abstract, and we will make everything else an AADL system. That would be the mission system, the sensor, and the air vehicle itself. This identifies that these are the blocks we care about. And that's it. We could now generate code just doing that. But let's dive in a little more and look at the internal block diagrams and annotate some ports with some tag values, since that gets more interesting. So here we're going to go into the air vehicle, And we've already got it set up with a sensor in the mission system and the cockpit being connected by ports. We're going to make these ports feature groups. They've already been typed as the feature group, so that's pretty straightforward. And once we'll do that, we can actually go in and set some things on these feature groups. Now, SysML doesn't care about the typing, but AADL is very particular, and so we need to tell it that it's inverse on one side or the other. We could also set the direction, but we do get that automatically since this particular model already has flows on the connections. Now, flows are a great AADL concept, and an ability to model them in SysML was a priority for us. So here, we will make a flow across what we've just seen. Each of these, the sensor has a flow source, the mission system a flow path, and the cockpit's flow sink have already been defined for brevity. So all we need to do is make the end-to-end flow across them. We start by creating a sequence diagram at that top level air vehicle and including all of the parts that we're going to need. We'll then name it, in this case, sensor flow, and we will reorganize, once we make it bigger, the flows into a logical order. So from sensor into the sink at the cockpit. Now, each of these parts need to be assigned those flows, and we can just drag and drop these onto their relative things. So there's the cockpit, and then we just connect them with messages. These messages are pretty straightforward to do, and once the messages have connected our flows, all we need to do now is make the sensor flow an actual AADL flow. Again, this is identifying that we actually do want to translate it, but it also gives us the ability to add those tags. In this case, once we do this, we will add a latency to it. All right, and we can just take that latency, which is a time range, create the value. In this case, we'll take one we've already got set up, which is going to be an alert max latency. You could also go and put that directly from the specification window down here from the tags and actually select from a list of what's available. That's it. Now we have a package with 4 components and an end-to-end flow. Let's take into AADL and run some analysis. To run the tool is pretty straightforward. We just do a right click, honestly. Yep, a right click, and nope, now it's freezing up. We're gonna try this a different way. And we would go down and generate the AADL there. Okay, sorry about that. All right. Nope, that's the wrong one, sorry. Let me try one more time. I'm not, okay. All right, we'll try again, it's working. So we're gonna change the name of the folder once we've got it there to generated AADL. I apologize, I don't know why this keeps pausing now. It didn't do it at all until yesterday, and then it started doing it. Let me just go back in. Oops, sorry, that's the wrong view. And we'll try one more time to get this to work. And otherwise we will just skip forward. Okay, so what would happen is we would, here I can try it this way. We would change it to generate to AADL. It would save it and give us the messages at the bottom to say what's going on. In this case, it was successfully generated, so we could load and perform the legality checks. We do report quite a few errors, but not everything. Once that's done, we could go, let's see if I can get a little further forward here. We would open SysML and we can import it directly into, or sorry, not SysML. We can open OSATE and import it directly from the package that we saved it in. From there, we can try to instantiate. There's the code. I don't think this is going to work for me. Okay, we would instantiate it. Well, here's the code that gets generated. You can see the flow, and it now includes the connections as well as the actual flow. And here we will instantiate it. I'm just going to skip forward for time. And we will run a very simple analysis. And we get an errors because we have mismanaged our addition. We need to change it. So we can go back in to here. We will change the 125 to 175. We will regenerate it and go back into OSATE, refresh our database or our code base, and go back, reinstantiate. The errors will go away. And just like magic, we now have no errors and it works. See what happens next. Okay, so moving along. I'm going to stop and talk about the question we always get, which is where is the line between SysML and AADL? And the answer is it depends. You can always expand the SysML model with refinements and new components and regenerate it, or you can refine and generate the AADL. In my personal opinion, the decision should be based on the preferences and skills of the developers. Are they more comfortable looking at diagrams and containment trees or textual code with graphical views? But there's other things that may influence that choice. So let's look at the options. The first case is where you want to keep properties at the SysML level. Our tooling allows many layers of generalization from SysML, so creating a cockpit package with the next level of detail is completely viable. We include the architecture refinement example model, which is 3 levels, but this can be extrapolated as much as desired. We also allow for custom property set creation. Our tool is flexible enough to allow developers to either use the provided profiles or to create their own if they have analysis tools that require specific properties. We provided details instructions for this, but the key here is that we can support translation of many different properties and architecture layouts into AADL. So if your source of truth is your SysML model for certain features or details, we can support that. Option 2 is the obvious choice if the system team has completed its high-level design and passed it over to a different team for looking at the embedded design phase. The increased fidelity needed here might be best represented in a semantically more precise language like AADL. We'll see whether this is going to work, but we're going to try and refine a package here. So we'll create a new package and we'll just call it refinement. And in this case, we're going to be adding some error data things, which is something that we don't currently support. So this might be a good reason to do this kind of refinement. So we're taking a new mission system called RMS, which is the refined mission system. And we're also going to create a new air vehicle with RAV, a refined air vehicle. And we'll create the implementation for that as well, and make sure that we refine the mission system that was in the old air vehicle to this new refined mission system. And then we can simply make our annex, and we'll use a rather trivial version here. And a bit convoluted, but basically we'll just have if the mission system fails, then we also fail here. And as soon as I fix the syntax, we should be all good to go. And there's our refinement. So just for the completion of the demo and to be complete, I've included here an example of how to do some integration from other packages. I'm going to skip that at this point for time, but it is there, so you can go back and look at the slides later for that. I do really want to spend some time highlighting a couple of real quick things here. The first is adding behavior information. Advenium has just concluded the sliced state linked interface compliance engine for data, which began work in this area, and we're currently expanding it under the Gumbo, working with a team from Kansas State. This work is mapping state machines and constraints from SysML into AADL as a pathway into the unified modeling languages. We're currently at the beginning of phase 2 of the SIBR, but things are progressing really nicely. The second thing I want to highlight is something that we've had a lot of interest in, which is the ability to map from non-AADL profile tags into an AADL stereotyped object. So there's a few complications here, including internal typing of the SysML elements and semantic matching, but we've developed the first prototype and hope to have more time for testing and further experimentation in the near future. And so that's pretty much it. I've told you mostly what we can do. Here's a few things that we don't do or we don't do very well. Some of these like models or modes are fairly big add-ons, and some things we're close on but haven't completed implementation yet. So I just want to thank you for allowing me to talk today. And if this website, you can get the tools. You can also find contact to ask us questions.
Thank you, Hazel, for your talk, and thanks for giving such an overview of the technology. We understand that it's complex, but it's also very important to support continuity across models, as I mentioned this morning. And a couple of questions I have about this this approach is that you have SysML and AADL, and Darren illustrated that in some cases you may have to move proof obligations or verification obligations from one level down to another. Like for instance, the SysML requirements cannot be validated at the level of SysML, but rather at the AADL level. Do you have any future work on bridging, for instance, SysML requirements and ALICE or agree verification checks?
Steve Vestal has really been looking into that, and we put it off a bit to push our things through, but it's kind of, our focus has been two prongs. The first being why it might be important to bring that information across and how much of the information needs to come across into the AADL. And the second is to how we would represent it. AADL doesn't have a requirements type. So do we use comments, or do we create a property set for it? Or what's the best way to really have that? And then we really, if we're going to do that, we need to do it seriously with traceability and consistency checks and be able to get that level in there as well. So I think kind of the two-pronged of which parts are important and how to actually make that happen. So that's something that we're hoping to add in the near future.
Yeah. One question we had on the chat is which SysML tool do you support? So I see that you have Cameo, Enterprise Architect, and Sparks. Is it something that is limited to those tools, or can you extend to those SysML tools if needs be?
It is currently limited to those tools because we actually do a plug into them and actually use their underlying features. I'm actually optimistic with when SysML moves to the next version that maybe there'll be some other options for cross-platform, but currently SysML going between platforms has not been, at least I have not had very much success with it. So we have only limited ourselves to those two tools. Yeah,
well, I agree with you. SysML v2 will be a great addition with their API, but yeah,
it would be fabulous.
We're not there yet. And I'm just curious about what is available and what is not, because I know that Cameo has a specific licensing agreement, but which part is today available if we want to download and play with it? Can you elaborate on that?
So the tool itself and everything comes on Cameo. Steve Vestal might yell at me for this, but I'm pretty sure we're perfectly happy to give out our profiles to anybody who asks.
So would be great.
So you can at least use the profiles, but the actual tool to generate the AADL is not available without the license. Okay.
Thanks a lot, Hazel. Just a reminder that the slides, and we'll discuss with you, Hazel, eventually to have also the video available after the event. Thanks again for the great talk and questions, and we are ready to move for the next one. Thanks a lot.
Great, thank you very much.